Hello and welcome back to the Musou game progress logs, I guess. So these aren't tutorials, this is more of just a log of what I'm doing. So like a live log, and then I automatically compress it all. Well, not compress it, like cut it all automatically using a Python script. So today we're gonna reverse engineer the mouse grab from last time, from the physics example. Because there's no tutorials on dots physics or ECS physics, whatever, we have to use the examples instead. So yeah, we're trying to modify mouse pick behavior, and we just call it controller pick behavior. So first I'm going to start up Steam VR and test it on Steam VR, yeah, using my Oculus Quest, using virtual desktop. Now before we start reverse engineering this more, we're going to look at the docs, I guess. Yeah, we're going to read some of these docs, and we're going to do more of the demos to understand how this works, how Unity dots physics work. Now actually, we're going to update this. I mentioned a Vortex thing in the previous episode, the previous log, and it actually wasn't part of the examples, it was part of the docs, and I pretty much just copied the code. So I pretty much just did this attract system and then put it into a project. And we're just going to convert that into the job system because it's currently just an ECS, but we're going to change it into a job system because more faster code. Yeah. So we're just going to copy this, I guess. Job. That's strange. Probably have to restart OmniShop. While we're doing that, we'll change this to ECS job system. Don't know why this is having some... Actually, I should probably show what it looks like first before I modify it. So pretty much, wherever this vortex is, it will push the objects up, pretty much. So this is like a hybrid ECS approach, where the vortex itself is a game object and it modifies the system. So here you can see it's getting the attract system right here. So it gets the attract system and then gives the center of the vortex this current position, this game object's position. And you can modify the distance and strength in the editor, so it's easier to modify the values. But we're going to change that to the job system, so it's much more efficient. Now, what do I put here? Execute, I think it was. Yeah, it was. I'm just gonna name this pause, and we'll just put. Now, if I'm remembering the job system correctly, this should work. After I change one thing, change this to job system. So this does this job on every every entity with physics velocity, translation, and rotation. I think I should do I parallel for. I don't know the struct thing, the implementation. I forget what it has an index. We'll just make it I job each, and that should still work theoretically. Yep, and it works perfectly. Oh, one more. Burst. That should be able to be burst compiled. Don't know if I can burst compile this whole thing. Apparently I can. So I successfully changed it to the job system. One thing I'm curious about is whether I should put it before a certain system. So right now the job system is doing it before the physics step. So I probably want to do it after build physics world, because I remember seeing it in a different example. So I want to do update after type of build physics. Wait, what was it called? It was called build physics world, right? Yeah, it is. I probably have to just import the library using Unity There we go. And do it before the physics step. Oops, wrong project. Alright, so now hopefully the objects won't clip through everything. I guess not. I think I probably have to use some sort of physics function. Something to do with the physics stuff, system. Like add force or something to make it work properly without it breaking. I don't know why it's going through so easy. Maybe I'm supposed to do it in parallel or something. I don't know. Alright, so this probably isn't going to be helpful. Oh, that's why it wasn't colliding. Because the collision box was too small. That's why it went through. Oh, there's a plane, so I need to put it. Can't be 0 because it's supposed to be a box collider. So now it shouldn't go through. Yep, it's all good now. Also, this should be... And for some reason, gravity is not affecting properly. Or maybe it is. The collider's just a bit high. That's probably not going to be helpful. So I'm going to go back to the example. And pretty much just go through all of them, I guess, to understand how dots physics work. So these letters are just a prefab, and they just have a physics shape and body. That's pretty much all they are. Alright, simple. So I'm guessing this is showing all the different types of shapes, physics shapes. So this is a sphere physics shape and dynamic physics body, cube and box shape, dynamic, capsule shape, cylindrical, convex shape, and a mesh, which is the most expensive. So that's pretty much the same as normal Unity's collider, box collider, mesh collider, pretty much the same thing. As a center, the box collider should have a center. So the shape, box, same thing as here, box collider, there's a center and a size. There's an orientation, apparently. Now I don't know what this convex radius is. Now in addition to what's the main difference with box collider and the physics shape is that the collision filter is on here, on the physics shape. And it can raise collision events or not. It's because it's ECS. I don't know, it's coded differently. This isn't a tutorial, I'm just observing at this point. I'll make a tutorial at some point in the future when I understand this more to get people started. But yeah, that's just basic shapes. Here it's demonstrating the different physics body types like dynamic, which is it can interact with everything, and the static where it can be collided with but it doesn't move at all. And then there's this compound dynamic monkey, which pretty much just have multiple physics shapes, and then you just add a physics body. So pretty much to make a compound object, you put multiple physics shapes, you put multiple empty game objects, and then add a physics shapes to combine it. Yeah, to make a compound collision thing. Now I read the documentation, and apparently it combines it all when you do that. So here, compound shapes. They will all be merged into one physics collider. So yeah, that's what this is. And this spawner, I don't know what. So that just spawns a bunch of random shapes to collide with. So still nothing too complex if you're used to normal Unity. And this is different weights for objects, different mass. Pretty much it's just showing that things can have different masses and it's scale, yeah, physics. So if I made all these to 2 kilograms each, this is going to go down. The one on the left is going to go down, hopefully. Yep, it goes down. So physics works. I haven't messed around with mass too much, but I eventually have to learn how to do it. So with these, they're setting initial velocities to demonstrate stuff, I guess. So this left one is demonstrating linear velocity, which is like up, down, left, right. Second one, angular rotations. And this one, linear and angular, is doing both. So you can see here, initial linear velocity, y10. So it's going to go up by 10. No, the velocity is set to 10 at the start. But since there's gravity, it'll go down. And with angular velocity, it just rotates that much. So if you know normal Unity physics, this will probably be familiar. I'm not too familiar with Unity physics, but I'm learning through ECS physics. And damping is just like, over time it'll slow down rather than spinning infinitely. So if we go back and we had 0 damping, I'm pretty sure it'll go on forever. If I do it for angular, it'll just spin forever until it hits something. Yeah, so let's just test that properly. So we're gonna undo, put that to 0 and set no gravity. So this is gonna just infinitely spin around. Since there's no dampening, it's not gonna change at all. And if we put dampening, let's say just 1, it'll slow down pretty quickly. Because I think it's like slowing it down by 1 every second, every frame, every physics step. So now it slows down. Yeah. So that's how damping works. It can also be known as drag. In the other programming language I used, it was known as drag. So yeah, it can also be known as drag. I'm pretty sure. Never 100% on these things because I'm no expert. I just observe. Now this is just changing gravity. So I'm pretty sure what this is doing is just getting the gravity and timing it by the gravity factor. So yeah, it's gravity. If I turn it to 0, it'll do nothing. It's pretty much takes the gravity. Yeah, I think minus 0.81 is how reality works, how real life gravity works. It's like minus 9.81 per second. I think that's what reality is. Not virtual reality, but reality. I read it somewhere that this gravity number is correct. Pretty much he gets that number, times it by this, whatever this is. So we just times this by 100, it's going to fall really fast. So this top one's just going to go drop down real fast. Yeah. And if we drag it, it won't even drag anywhere. This gravity is too powerful. Yeah, gravity. Now center of mass is where it gets kind of complicated, for me at least. I tried messing around with these values because I want to make something that automatically tries to stand up by itself. But this is pretty much the thing that you want to make stuff go straight back up. So with a normal cube, that wouldn't work. But since the center of gravity is set weirdly, it stays like that. Now, I don't really get how this works. I tried tweaking with it. In a previous video I did a lot of tweaking, and probably the best way to use this is using one normal center of mass object and connect it with another object that's had its center of mass changed. But changing these values, I don't understand how it works. It's really weird. But you could probably make some interesting physics using that. Now this is pretty much the same thing, but it's more on the difficult part, the inertia tensor. Well, actually just all this is pretty difficult for me to understand, to control. Like I changed the values and it somewhat works how I expect it. So if I drag this, it's gonna go back up or fall off. One thing I've noticed, if you make it like down a lot, make the center of mass really low, it'll stand up quicker. But if for some reason it goes upside down, it will rotate like really far. So when it tumbles, it goes weird from my experimentation. So I need to learn a bit more on how this works. See, that's what happens if you rotate it. If it does a flip, it just goes crazy. Now, I haven't looked at these examples before. I'm guessing it's like dampening, but when you collide, it changes. So with a VR hand, I probably want to put a lot more friction. So somewhere here, there's friction. Hey, here. Here's the friction right here, 0.1, and restitution. Alright, so let's see what affects it. So the lower it is, the more friction, the more it stays still. No, it slides more, which makes sense. So this has 1 friction, and there's different ways to do it, I guess. So I probably want a high friction, and I'm using like a player hand or something, because I want to do like some sort of climbing mechanic in VR. So if I push down and move to the right, yeah, it drags really slow, which is what I want for climbing. Now restitution, I have no idea what's going to happen, so we're just going to play and see what happens. So it's like bounciness. So instead of doing a ragdoll, I could probably just put a high restitution. Is it higher or lower? So a high restitution will make it bounce more, and a lower will make it stop instantly. So if you want your enemies to comedically fly away and bounce, just put high restitution. Alright, I get it now. Now collision filters. I haven't messed around with collision filters yet, but I assume it's kind of like physics. It's like this, I'm pretty sure. Like how Unity physics belongs to static environmental, dynamic environmental. So this is defined somewhere. I think it's in common materials. Yeah, right here. So you create a physics, I think a material, wait, let me just see, category. Well, let's just try all of them. So this one is body tag name, this one is material tag. Category, that's the same as layers, I'm pretty sure. And physics material is like a normal physics material. You can find it, there should be a physics material. So yeah, it's exactly the same as physics material, but a few more things. But they act very similarly. Yeah, so physics So that was physics, category names. It's like layers. So it belongs to red. This one doesn't. Let's just play and see what happens. So pretty much it's filtering which should collide and which shouldn't. Same thing as normal physics, Unity physics, but implemented in a different way. That's pretty much ECS. It's all implemented in a different way. So these static cubes are just everything. There's red, just collides with red stuff. It just collides with green stuff. Blue. And this collides with dynamic and green. Does it collide with this one? Belongs to everything. So it does collide with the floor. Let's check it again. So all the spheres should collide with the floor. Well, the black one isn't. The black sphere isn't colliding with the floor. Oh, it only collides with that. That's weird. I probably have to make this collide belongs to static environment. Now it should collide with the it belongs to nothing. So if it belongs to nothing, it collides with nothing. So I just put this dynamic environment. Alright, so if the collision filter belongs to nothing, it collides with nothing. Makes sense. So that was part of the material problem. Now for the interesting part, triggers. Now this one, I have less of an idea of what happens. Because with normal Unity, you attach a script to a game object and it'll have on trigger enter or on trigger exit, or it has a lot of on trigger stuff or on collide stuff. So if I just go to any mono behavior, they all have a on collision, on trigger. They have all this stuff on the mono behavior, but we're using ECS. So I'm quite interested in how you would implement triggers and collisions. So we're probably going to spend much more time than the other stuff on this. So these two are just triggers, as on is trigger and it's just a box. And it's converted to an entity and it has this script, trigger gravity behavior. Alright, so it does a conversion. So it gets these two values, which is a mono behavior, which you can modify in the inspector. So these two values. And after this gets converted because of convert to entity, this will run. So it'll create a new component, new entity, and it'll put this component inside. And using the values from the mono behavior, the inspector values, it'll put it in this component. And here's the system that does the trigger stuff. So this is the important stuff, I guess. This is how you do a trigger in ECS. So it creates a build physics world variable and step physics world variable, and it gets the system. So it gets this. It gets the build physics world. So these two variables are build physics world. So it gets this system from the world, and then it gets the step system, step physics world. And this entity query trigger group, pretty much it gets every component, every entity that has the trigger gravity component. This way, instead of looking for all the entities that have it and then doing the job, it will already know all the entities required to do the job on. And here is the actual job. But before we go there, we'll go to the on update. So, trigger gravity factor. Where is this trigger? Oh yeah, here. How does this work? Get component data from entity. How does it know which entity to get it from? So, what is this part of? Component system base. So is this like an array of objects or something? Trigger factor. I have never seen this type of code before. Public T, this entity. So I don't get how this works. Trigger gravity factor. So this component. So it'll be T. So trigger gravity factor will be here, wherever there's T. Trigger gravity factor, this entity exists. Okay. This line is just confusing me. This array? So I'm just going to assume that this is getting an array or a list of some sort. And so I think this is getting the trigger gravity factor array, if that exists, right here. Oops, I forgot to start the timer. So it's 1 hour and 23 minutes. I'll start it now. I wonder if I could just change that. So yeah, the time is a bit of a late start. I kind of want it this time because I'm doing a lot of thinking. Anyway. Still trying to figure out how this works. So what is a trigger event? So this should be running every frame because it's on update. So each frame it's doing this, calling this. and it's executing this. So it's checking all this and then doing that. So are these balls triggers or no? They're physical. So if both of these objects are a trigger, then it won't. Is not a trigger. No, wait. If they're both triggers, it won't do it, as it says here. So this is like a listener. So if you know what events are, these is pretty much a listener. And it's only checking if in this group. So this gets every trigger gravity component. There's an ECS, it's all in arrays, so there's a trigger gravity component right here, and it checks if one of them is part of the trigger gravity factor group. So it's checking if trigger gravity factor is checking. No, this job system is checking if it is one of these, one of the gravity factors. So if, say for example, two dynamic objects collide, this will be false. These two will be false. Alright, so we're going to go with the test case. Two dynamic objects. So entity A will be ball 1, entity B will be ball 2, and then it checks if ball 1 exists, or ball A and ball B. Ball A exists in the trigger gravity group, which will be wrong because it's not. It's a dynamic thing. It's not one of the gravity factor trigger boxes. So they're both going to be false. Now this will not activate because that will return false for both. Now is a body dynamic? Physics velocity group exists. So these physics ball things, they have a physics velocity. So it'll pass on to the next stage. It's part of the physics velocity group, which you give here. So body A is not a trigger, so that's false. Body B is dynamic. Body B is not dynamic. That's false also. This won't run, and these both won't run because they're both not triggers and they're both not dynamic. They are dynamic, so this is false. So we'll go to this part. Is body A a trigger? This will be false, so it'll be entity B. I think this is how true false, the question mark true false goes. So they're both going to be false. So it's entity B and A. It passes in that entity. It's interesting. There's no check to see if they're... Shouldn't there be a check to see if one of them is a trigger? Oh wait, body A false, and false again. So it's B and A. So it gets the physics gravity. This will be null. The trigger entity will be B. In this case, it'll be ball B. What? So if I make these two collide, they don't change. Alright, so probably this is somehow only called when a trigger gets touched, pretty much. A trigger collides with something. So I was wrong about this being a listener. So somehow there's a system somewhere where it will call this, or maybe it calls it every frame, and when this job starts, it'll see if there was a trigger event. And if there was a trigger event on that frame, it'll run this. And one of the entities has to be a trigger. So we'll pretend entity A is a ball, entity B is a trigger. So A is not part of the trigger gravity group because it's not a trigger. B is a trigger, it's part of the gravity group. Then both not triggers, body dynamic. A is a dynamic body, B is not because, well actually, can triggers be dynamic? No they can't because, wait what? Can triggers be dynamic? Although how would that work? I don't know how that would work if a trigger was dynamic. If I just make this a trigger, it should still have gravity, but it's just a trigger, so you should go through that ball? Aha. So you won't normally put a trigger to dynamic, and it's assuming that, so that's why it crashes. Because here it says component with trigger gravity has not been added to entity. So the trigger entity, right here, is where it crashes. The trigger entity, you'll try and get the trigger gravity factor component from the trigger entity, but the trigger entity is a dynamic and not part of the factor group. So there's no check if it's a dynamic trigger. I mean, you wouldn't really do that. Well, let's just put it there. Although, no point. Let's put it in our Trello instead. Let's put our notes. It's good to make notes. Avoid mixing triggers with dynamic shape bodies. I guess that's what I want. I'm trying to think of a situation where you would want a dynamic body on a trigger. What happens if I put it kinematic? I could think of situations where I would put it to kinematic. Yeah, it messes up. So that's really important with kinematic, because think of a hand, a VR hand, and you hit something, and you don't want it to collide. You just want to interact with it. This doesn't work. I don't know where I was going with that, but there is situations where you would want a kinematic body with a trigger. Would you? What if we remove the body and see what happens? Is it still affected by gravity? Alright, so it's not affected by gravity. So you want to do a check if it's kinematic or not, or dynamic. So if you want really flexible code, you would want to check if it's a dynamic trigger or kinematic trigger. Figure out a solution to check if something is kinematic or dynamic. So if I quickly play and then pause, I can look into the entity components and see if a physics body has any values I can read. Looks like it doesn't. So physics body is unreadable. Best way to deal with theoretical ways to deal with dynamic kinematic physics triggers. Put them in another layer. In this case it's collision filter. That's actually all I got. I don't know how the tags work, so I'm going to try that. So these objects will just belong to something else. Category 10 will be trigger ball, physics ball. Collides with everything but physics, and these three will be physics. So this should just fall down to the bottom. Yep. Even though they're both triggers, it still does it. So this is not checking if it's a trigger. It's more accurate to check is body a grav factor. That's a more accurate thing than trigger. And with this is body a phys velocity. So the way this is worded makes it a bit confusing. For this example, it makes sense, but if you're trying to learn ECS, it's probably not a good idea to call them trigger checking, when it's just actually checking if it's part of the trigger gravity group. I guess you could do one final check. If dot exists does not exist, trigger entity, then return. Now if we just returned all these to normal, it should still work because of that check. It's pretty unlikely, but not impossible. So I'm going to put this all to everything. Put this to everything and everything. That's still a trigger. We're going to put this dynamic. Doesn't matter. Now it should just go through the ball and hopefully it doesn't cause a crash. Yep. I can't call debug.log because it's in a job. Maybe I could temporarily do it. It'll throw up some errors, but we're just testing it. Entity does not have trigger gravity factor. Yeah, we'll just put that. Now it's going to throw up some errors because I'm using static stuff in a job, which is very bad. Oh, there's no errors. I'm surprised. But if you do it in more than 2 objects, yeah, errors occur. See, it eventually crashed, but now we can confirm that the logic works. I wonder if I could make a debug.log thing. So if we make a native array of string debug info equals new native. Wait, why isn't string non-nullable value? Is there a non-nullable string I can use? Is there a binary to text I can do? Is there a non-nullable string C#? Is there a native string system.string? How to make non-nullable string? Oh, there we go. So put job handle.complete to check if it's completed, then we do that. Oh yeah, and of course with native arrays, we need to dispose of them. Now I should have a makeshift debug.log. Unmanaged. I don't know what that means. No managed. That's a new problem. Alright, so it's probably going to be more complicated than I thought. So instead of creating a string, we're just going to make an int. So this is just going to be an integer, or maybe I can make a native list, and then dot add, and do a switch case. Switch. No, first we do a for loop. Debug. Do switch. Debug int I. Switch. Debug int. Didn't camel case this. Case 1, 2, 3. Debug log. So we're pretty much making our own error code. Break. Debug.log, and we'll put entity doesn't, and entity doesn't have gravity factor. And then we put add 1, 2, 3. There we go. Error 3. So I guess that's one way to do debug.log using jobs. So let's do a bit of review. To do a trigger, we need a group to check against. Oh wait, let me start again. Trigger event is called when a trigger interacts with something. And this trigger event has an entity pair, body index pair, glider pair. So ignore everything below here. This is the data we come up with. The data that appears when a trigger is activated. And this is for any trigger. That's why we have this trigger group to check if it is part of a trigger, if it has something that we want to check against. So these are stuff we want to check against. We want to get the arrays, the data that we want to check against the data array thing. The component of ECS, entity component system, the component of the entity component system. We want that array, the component array, which what this does. And if we don't want to collide with certain objects or triggers, we use the filter. Then this won't be activated. Alright, starting to understand it. So with this, I'm going to probably make a dupe. Because I usually sync up this. I usually do a git pull whenever I plan to use this, so I get the latest version of this examples. But since I modified this quite a bit, I'm going to make a copy. I'm going to save this and rename it. Oh yeah, a bit off topic, but I plan to do some Google Surat at some point, but that's probably going to be after GCAP, after Melbourne International Games Week. I'll probably be doing Google Surat stuff. But that's mainly for high fidelity 3D stuff. And I don't plan on doing anything too high fidelity, too HD, just yet. But it's something I'm pretty interested in. It's what the Star Wars game on the Oculus Quest uses to get like high detail environments on the Oculus Quest. Anyways, back to triggers. So now we have a better idea on how triggers work. Now this isn't a tutorial, but maybe it might help if you're doing ECS. Now contacts. But before we continue on, I might take a short break. I'm going to stop this recording and we'll continue soon with contacts, whatever that is. I want to take a break because I want to take all that I just learnt in the triggers and stuff, and for the recording to be easier to convert. So I'll be right back.